In this lab, we are going to integrate Azure DevOps with AWS CloudFormation, and we are going to do it with the help of plugins available on Azure DevOps servers. So we learned a lot of concepts in previous labs, and this is where we are going to put all those learnings into practice and then create a seamless pipeline to deploy a CloudFormation template so that whenever a developer makes some changes into the source control, he can commit it into the Azure repo and it get automatically built and deployed into AWS environments. We are going to cover a few things. The length of this lab is a bit longer than the others. We are going to explore Azure DevOps extension marketplace very quickly. Use one of those extensions to build Azure DevOps pipeline, and then use different authentication mechanisms to authenticate with AWS. One is we are going to attach a permission into our build machine and then use that permission to do a CloudFormation deployment. We are going to use IAM user credentials to do a deployment. And finally, we are going to use assume role method to do a deployment. So these three authentication and authorization methods we already discussed before, but this is where we are going to put them in practice. You'll also look at fine-grained permissions, how to attach them, and also how to maintain your infrastructure as code in Azure repository. So in high level, let's explore what we are going to build. We are going to have the same network template, but in this case, we are going to keep it in Visual Studio Code, put it into Azure repositories, and from the time that you commit it, it's going to automatically kickstart Azure pipeline to build that. And that pipeline will run in a build agent, and we will attach certain permissions into that build agent. And this build agent is going to invoke AWS CloudFormation, and that CloudFormation will provision a very simple virtual private cloud and a private subnet. So let's see how we can do this integration. I'm in my development machine, and I have logged into Azure DevOps server, which is installed in this machine. If you are not familiarized with Azure DevOps server, please take a previous lab where we go through some parts of Azure DevOps server like pipelines, projects, plugins, how to invoke a pipeline. So at this stage, we expect that you are familiarized with Azure DevOps server and you know concepts like pipelines, build agent, permissions, to name a few. So we are going to do a deployment of CloudFormation template using Azure DevOps server. And there is a project that I have already created called My Cat App. So if you go into this project and then select the pipelines, you can find that there are two pipelines already being defined. So one is there to deploy, give an example how we can deploy using pure PowerShell. The other one is explain you how to deploy CloudFormation template using plugins available for TFS or Azure DevOps server. We are going to learn My Cat App PowerShell pipeline, where we deploy the CloudFormation using pure PowerShell in the next lab series. Therefore, we don't need it for this lab session, and we are going to disable it. To disable it, go to this folder icon and then select My Cat App PowerShell pipeline. So this we don't need it. We are going to study it in the next lab series. So we go to Edit and then go to Options. And if it is Enable, make sure that you click it Disable so that this pipeline will not get executed when you are making changes into the source control system. Make sure you save it so that this pipeline is disabled. So if you go to Builds, only My Cat App plugin-based pipeline is enabled. To make sure that it automatically builds whenever you make some changes into the source control system, again go to this folder, select My plugin-based pipeline and click Edit. Under the options, make sure that this pipeline is enabled. Make sure that you save it. And also you need to enable the triggers and make it a continuous integration job. So every time when somebody make changes to this source control system, and make some changes, it get built. So also make sure that this is saved. So your my cat-tab plugin based pipeline is enabled, and it get automatically triggered whenever a change is submitted. So what we are going to study now is this pipeline, my cat-tab plugin based pipeline. So select that, and we'll first try to explore how this has been configured. So if you edit this, you'll find that the normal pipeline is there. I have set up the agent pool as AWS build pool. So one of these build pool, AWS build pool has a build agent, and the build agent is running in our build machine. So if you go into the build machine, so this is the build machine that is running our build agent. So we already discussed this one in previous labs. So what we're going to do now is to explore this pipeline. It's a very simple one task pipeline, and it has a task called AWS CloudFormation create update stack. And the region, how I added this is click add here. And this came as part of installation of some tools. So you can find that there are multiple AWS tasks like S3 upload, Elastic Beanstalk deployment, AWS Lambda invoke, to name a few. If you don't have these plugins in your company system, you can go to the marketplace and then search for AWS tools for TFS server or Azure DevOps server or Visual Studio Team Services, and then install it. So this is already installed. We already discussed the process of adding this and the things related to that. And that's how I got these plugins. So if you explore this CloudFormation create update stack, you can find that it expects what's the region I'm going to run it. Here I'm purposely not giving credentials to showcase you different ways that you can provide credentials. And the stack name is cat home. We already know that the permission that we are going to provision expect the stack name to be cat home. If it is a different name, it's going to throw a security exception. The template file is a local file which is available in the Git repository that comes with this project. And the network template is the same template that we saw when we deploy the CloudFormation template using scripts, but through PowerShell. So you keep this all the features default, log morning during the playback, everything is good, enable, so this task is going to run. So this is how you configure the AWS CloudFormation creates update stack plugin. So let's queue this and then see what will happen. We are going to use AWS build pool. So this build pool is already configured for you with a build agent. So let's queue this. And the build is running. It's of course going to throw an exception saying that it doesn't have permissions to run it. So let's check what will happen. You get an error saying that assume role DevOps built machine role does not have permissions to execute this. The reason for this is, as we discussed in the command line execution, that this CloudFormation template is going to invoke certain AWS services, and also when you're provisioning CloudFormation template, you need to have certain permissions and you need to have access to do that. So we don't have access in the build agent. So what we are going to do is to attach certain permissions into the IAM role of that build machine. So let's go and do it. So I'm in my build machine. I have selected it. IAM role is DevOps build machine, which our task complaints does not have permissions. So let's go to it. And you can find that as of now, it doesn't have any permissions. I'm going to attach a permission. There's a customer manage customize policy already been defined. It's the same one that we use, we attach to our development machine when we ran our CloudFormation template from PowerShell script inside that development machine. So let's attach this one to our build machine also. So this is the policy. If you want to go through that, you can read what is the content of this. And the same policy is also available if you want to copy paste in this network template. It is available under the folder cdiv mycat tab. So we already attached this policy to our build machine. Now it has permissions to execute the task defined in the CloudFormation. So let's try to run our pipeline again. So queue a new pipeline. This is the pool. Queue the new pipeline. So you can find that it's now started building. Hopefully this task will successfully execute. Yeah, it's getting executed. So if you go into your CloudFormation section of your AWS console, you can find that the cat home create in progress. So make sure that you have deleted the previous execution of this cat home, or you can do a clean installation. If you don't have the cat home already in this as a stack, it will be create in progress. If you already have it, it will be update in progress. And at some point in time, this will provision certain resources. The resources defined in your CloudFormation template. So if you go into the resources, you can find that it's going to provision one subnet and one VPC. So this one is defined in your, if you go into your Git repository and then select the network template that we are provisioning as part of this execution of the pipeline, you can find that it's going to provision one VPC and one subnet. So CloudFormation template is still in create in progress. So let's go back and then check. Okay, now this create complete. So if you go into your VPC section of the AWS console, you will find under subnets, subnet has been provisioned for cat home. And your VPC, you can find the cat home has been already provisioned. So far so good. So let's go into my pipeline again. So this is what that got executed. So you can use a similar method to create a new pipeline and then add the plugins to deploy a CloudFormation template. Now there's one more thing. If you go and edit this, in this create update stack, there's another method that you can provide AWS credentials. And that is using this field or given here. So instead of defining the policy in the build machine itself, we can define the credentials in the plugin itself. So let's see how we can do that. First, to make sure that we are not going to use the existing credentials of our build machine, let's for the moment remove the credentials defined there. So we know that we attach the permissions in this IAM role. And the permission that we attach is mycat tab policy. So imagine that we don't have this permission, so let's delete this, detach this. So the build machine is in its original state. It doesn't have any policies attached. You can define the permission in the plugin itself. And to do that, you can go to AWS credentials and then create manage. You can add the new service connection. It's going to be AWS. And the connection name, let's say AWS mycat app connection. And I'm going to define what's the access key and what the secret key is. So these values that you find here are not valid. So let's create a user and then create access key and the secret key. We all know how to create a AWS IAM user. Go to IAM and then go to users, add a user, the name something like my test user. We are going to give programmatic access. Click next. We are going to attach an existing policy. So this policy is already defined for you. It's a customer managed policy. The name of the policy is mycat tab policy. If you want to exploit, you can click it to check what is inside. So we attach this my cat tab policy. Click add tags, next review. My test user is ready, and then create the user. So this will give you the access key and the secret access key. Let's copy this access key and secret key and then set the connection. So copy the access key, go to this section, AWS connection, put the access key, and the secret key is this one. Copy it, paste the secret key, and now you have AWS My Cat Tab connection. So the connection is created, My Cat Tab connection, and we can now use this connection to execute that task in the pipeline. So if I go into my pipelines, go into my Cat Tab plugin based deployment and edit it, and then here I can specify what's the credential that I want to use. In this case, my AWS My Cat App connection. So far so good. And then save this. So the difference here is that I'm not attaching the permission to the built agent, but I'm specifying the credentials in the plugin itself. Go for our CloudFormation. We already have a CloudFormation being defined. It will be an update if we execute it again, but so because we provisioned this one before with the help of EC2 instance profile. So let's just for the moment execute this again. It will not make any modification because the content is pretty much the same, but it will do an update and then realize there's nothing to provision. So cat tab successful, there's nothing to provision because I didn't make any code changes. So let's delete this stack so that we will start from the scratch. So the CloudFormation template, the delete is completed. If you go into the deleted one, you can find that it's been deleted. So let's try to execute our pipeline again. So you can go to the pipelines and then queue a new pipeline. So make sure that you select the correct pipeline. In this case, it's my Cat Tab plugin based one. Queue a new one. So the difference here is that we are executing this, but the built agent, in this case, if you go to the EC2, does not have the IAM permissions attached. So it has a role, but that role doesn't have permissions to execute the CloudFormation templates. But we have specified in our plugin. So let's run this and then see what will happen. You can find that it's executing. Create update stack. So the task is running. So if I go into my CloudFormation section of the console, you can find that it's creating in progress, which means that it successfully started executing the CloudFormation template. And the permissions for that, it got through the credentials we created. So if you go into your project, my Cat Tab, you can go to the pipelines. So the plugin is here. So if you edit this, we define these permissions here. So if you want to manage these credentials, you can go to the Manage Credentials. And it's under the project, the general settings. And you have this set of connections that you can define. You can have multiple connections for multiple pipelines. So that if you have one pipeline that deploys into production, another one that deploys into pre-production, you can separate what permissions are allowed in each users so that the production pipeline will not get affected by a pipeline that you are trying to deploy through development. As we discussed in the PowerShell learning series, we know that there's a method where you can define temporary credentials using secure token service assume role method. So in the same way, you can define temporary credentials in these plugins using assume role. So let's see how we can define a role and then assume the permission of that role to deploy the solution. So if you go into your AWS console and let's go into the IAM, the user that we have defined to execute this plugin, if you go into the user section, this is the user we created, my test user. And that test user has this permission called my cat app policy. So let's for the moment remove this policy. So the user does not have any policy to deploy. And also make sure that your EC2 build machine does not have any attach policy that allows it to deploy. So this is the IAM role of the build machine. And if you go into that role, you can find that there's no permission defined for the deploy my cat app related artifacts. So if you queue the build now, let's go to the pipeline and then select the my cat app plugin based pipeline and then queue a new build. This should ideally throw an error because this user that I'm set up in the connection does not have permissions to execute it. So you can find that my test user is not authorized to perform CloudFormation create stack. The reason is that we just remove the permissions attached to that user. Now what we are going to do is allow this user to assume a role and then define the permission in that role. So let's see how I can do that. Go to IAM section and first define a role. So let's go to create a new role. We are going to select EC2 base service, allow EC2 instance to call AWS on your behalf. Of course, we are going to change it where we are going to grant the user to assume the role. So for the moment, just select this and then click next permission. We are going to attach our custom manage policy, my cat app policy, to this role. So remember, we are attaching this role, this permission to the role. Let's call this one my test role. So I created my test role. In this case, my test role is trusting EC2 to assume that role. So what I want is my test role to assume, my test role to trust the user I created. So my test user is here. So click it. The Amazon resource name of this user is given here. Copy it. And I'm going to set the role, which I just created, to trust this user. So go to the role. And in the trust relationship, edit the trust relationship. So I want to trust the principal, in this case AWS resource, which is a user. So I'm creating a role which trusts this user, which can assume that role. So update the trust policy. So what I have created is I have a role called my test role, which trusts this user, so that user can assume this role. So let's go to the users. Now you can see that the user does not have any permissions. The role is there. My test role has the permission, my cat app policy. So let's copy the role ARN, or the resource name of this role, which is given here, and then configure our connection to assume this role. To do that, go to your TFS. So we find that this failed. So let's go to our pipelines, select my plugin based pipeline, edit it. You can find that this task use my cat app connection that we created a moment ago. Click manage. We are going to update the service connection, and the role to assume we are going to give here. So in this case, it's going to be the role my test role. So secret and access keys are good. Click OK. So the difference here is that now the user does not have any permission, but the role has, and the user is going to assume that role. So let's go to the pipeline again and then queue a new build. So it will kickstart the build. Like before, it will execute some steps. Create up a stack. It's going to check out the content. It's going to execute it. So execution was successful. As you can see, now it successfully deployed it because the user assumed that role. You may be asking why we learn different methods of providing the credentials and why we learn about creating temporary credentials to deploy into different environments. So let's see what are the reasons. Imagine that you have a source code, an environment A, and you need to limit the permissions to deploy on this environment. And you have an environment B where you want to grant an IAM policy B just enough permission to access this environment. So anybody who is going to deploy into these environments needs to get those permissions to deploy into them. So there are multiple ways to do that. Method number one is, let's say you have Azure DevOps server like this. You can have two pipelines, and pipeline A will use build machine X to deploy, and pipeline B will use build machine Y to deploy into environment B. And of course, to grant permission to deploy into environment A, you are going to attach an instance role with just enough permission to deploy into environment A. And for the build machine Y, you will attach just enough permission to deploy into environment B. So of course, the challenge here is that you are going to have one build machine for each environment so that you can deploy into those environments. So this is one method, but there are different ways that you can do this. Another method is that you use one build machine instead of two build machines. And you have these two pipelines to deploy into two different environments because their configurations are different. So you have this task P and task Q. So this could be a CloudFormation deployment task. It could be Elastic Beanstalk deployment task. It really doesn't matter. And then you create a user A with access key and secret key. And you create a Azure DevOps connection, attach it to the task. Same for the policy B. You create a user with access key and secret key, attach the IAM policy B to the user B, and then create a connection inside Azure DevOps server, and then attach it to task Q. So of course, when you are deploying this, the task P will use the access key and secret key when it is executing, and then deploy into environment A. When the task Q is using, it will use user B with its access key and secret key, which will give access to environment B. So this is another method. The method number 3 is more elegant. You create one IAM user with permission to assume role and B. You don't define any permissions for this user, but you define in the role that this user is trusted to assume the role. You then create a connection like we created before. You create a role, and this role A trusts this user to assume itself. Role B also trusts the user to assume that role. And then when the task P executes on the build machine, it assumes the role A. It can do because it has the rights to do so. And the role A, of course, has permissions to deploy into environment A. So this task can execute. And same for the task B. This task Q, when it try to deploy into environment B, it assume the role B and then deploy into environment B. So in this case, you are going to have only one IAM user with one access key and secret key. You can have multiple environments with multiple roles. And when it tries to execute, it's going to take temporary credentials to deploy to the environment. So it's more secure and more manageable. You can find that my cat home is already provisioned. And if you click it, you can find the resources it provisioned. It provisioned a VPC and a subnet. So it's usually a good practice that if you provision something to AWS using a CloudFormation, any modification to the resources associated with that, also you provision through CloudFormation. So you don't manually fiddle around with these things, although you can do, You can add, for example, another subnet into this VPC manually. A good practice is to maintain everything in the code so that somebody else in the future wants to execute the same changes, has all the traces of what happened in the infrastructure as code. So let's say I want to add a new subnet into this. So what's the work process for that? So if I go into my development machine and I open my Azure DevOps Server Integrated project. So the project is, if you open the folder, it's under cdev mycat app. So this is already, I have added all the Git locations into the Azure DevOps server, and this is linked. For example, if I open a command line and go to cdev mycat app, where this location is, and then type git config get remote origin URL, you can find that it points into dev default collection mycat.git mycat app repository, which is the repository of this pipeline. So this is a link to this project. So imagine that this is the network template that the plugin deploys. If you go into your Azure DevOps server, under files, you can find the same file over here. So this is already committed file. So let's make a modification into this file. So instead of subnet 1, let's add another subnet. So this exercise we already did in our script-based deployment exercise. So let's add the subnet 2. And then let's add it to availability zone 1, and let's give it CIDR block like 10.0.20.24. Save the file. Make sure that you save the file. So once you save the file, it's not committed to your Azure DevOps server. So if you go into this source control system, which I have integrated the Git repository, so you can find that there's a modification for that. So it's time to commit this. So I want, when the developer commits this, to go there and then automatically builds it and deploy it. I want to run this pipeline every time somebody makes a change to the code. So let's go into the edit and go to the triggers and make sure that you set up enable continuous integration. You can add batch changes while a build is in progress, which means that if 2 developers make the same changes, or 3-4 other developers also make different changes, and it went into the system and there's a build already happening, it's not going to execute all those changes as separate builds. It's going to execute one big build that accumulates everything if a build is already running. So we don't want that. We don't have multiple developers working on this. So let's make enable continuous integration. And once you do that, every time you need to save it, of course. Make sure every time when you make these changes to the pipeline, save the pipeline. So I save the triggers. If I go into the builds, whenever I now make any changes and commit it to the system, this will automatically start a build. So let's try to simulate that. So I'm on my team system. You can find that these are the changes I made. You need to commit it. This will commit only to locally. Let's give it a name. Let's say added a new subnet with CIDR block 10.0.20.24. So I did that. And so commit the message. So this commit locally. So of course you need to push these changes. So select this squiggly button and then click push. This will push the changes to the, you can find that added a new build with CIDR block. That comment is picked up as a new build. And now it's running the steps like before. But in this case, it's going to be an update task. So if I go into my CloudFormation template, if you go into CloudFormation, it says CloudFormation. You can find that it's did the update also. Update in progress. So update completed. It already did the update. And if you go into the one, you can find that what kind of update it did. It created a subnet 2. So that one is here. So if you go into now, these resources it provision, you can find that it provisioned the subnet 2. So if I don't want this, again, I'm not going to manually delete this subnet. I'm going to do it through CloudFormation. So I go to my development machine. So let's say you don't want these changes that I made. So I go into network template. I don't want this new subnet I provision. So you make the changes in the code. I don't want any of this. Save the file. And then it will appear as a change here in the source control. Commit it. Removed the subnet. So you now know everything is now tracked with comments and proper coding. And then you push it. So when you push it, of course, it's going to start a new build. So it started already a new build. It's executing the steps. And if you go into your CloudFormation, update in progress, in this time it's going to delete that subnet that we mark as not existing in this CloudFormation. So if you go into this and select resources, at some point in time this subnet 2 will be gone. So let's wait a bit. Update completed. Go to the stack. You can find that resources only subnet 1 is available.